as well as it can be fault based also. In fault based testing, the testing strategy, we design the test cases in such a way that they look for certain types of fault, and the test cases are designed in such way. Okay, what is done with fault based testing? We design the test cases in such a way that they are used to detect certain types of fault. Then comes the coverage based testing. What is there with the coverage based testing? In coverage based testing, if the test cases are designed in such a way that they execute certain elements of a program. Suppose we want that a particular code of a program must be tested in order to check for the correctness of the program. For those types, we go for coverage based testing. There are various types of coverage based testing, as we will be seeing here. These are statement coverage, branch coverage, and path coverage based testing that will be taking up one by one in this case. Now, one term that will be taking up is the testing criteria for coverage based testing. The set of specific program elements that the testing strategy requires to be executed is called testing criteria of the strategy. So what is there with testing criteria of the strategy? It is those program elements which needs to be checked by executing by giving inputs, and which make sure that certain part of the code is executed. That is known as the testing criteria of the strategy. Now we have two types of testing. We can compare any two testing techniques as stronger or weaker one. How we can say a white box test strategy is said to be stronger than other if the second strategy, which we are taking it to be stronger one, it is able to detect all the strategies that are covered by the weaker testing strategy. In addition to that, it will also cover some additional errors which were not covered with the first testing strategy. So it must be clear what is there with stronger testing strategy. In stronger testing strategy, it should be able to find out some errors additional to the testing strategy followed by a weaker testing strategy. That means the errors detected by weaker strategy plus some additional errors are detected by a testing strategy that will be considered as a stronger testing strategy. Now, as if we are seeing, if the stronger testing strategy has been performed, then a weaker testing strategy need not be carried out, because a stronger strategy will be able to cover all the errors that are detected by weaker testing strategy. So it is better to follow a stronger testing strategy. Now we'll be taking up the this example over here. Here in the first case, here we are looking at two testing strategies, A and B. Now A is considered to be stronger one, B is considered to be weaker one. Why A is considered? Because the errors that are covered by B, that will be only this area. This is errors detected by B. But A, in addition to this, it is also able to detect all the errors. So what we say that B is a A is a stronger testing strategy than B. Similarly, if we look at the complementary testing strategies, if the errors detected by A and B are different, then we say that they are complementary testing strategy. So this is all with the stronger and weaker testing strategy. Next we will be looking at the statement coverage. Now the principal idea behind statement coverage is that we cannot find out whether there is error in a statement or not unless that statement is executed. So what is there with the statement coverage, the principal idea behind that is that a error cannot be detected in a statement unless that statement is executed. This is followed in statement coverage. So what is there? We should design the test cases in such a way that we should be able to it should be able to execute each statement. Suppose we are given with this program code. So, while x not equivalent to y, x greater than y, x then x is equal to x minus y. This is the case. So what will be the effective the test cases for this? It should be, we should design the test case in such a way that it should be having both the cases where x and y are same, where x is greater than y, where x is less than y. If this is the test case, we'll be able to execute each and every statement. Then comes the branch coverage statement. What is there with branch coverage statement? In branch coverage statement, we should be designing the test case in such a way that it should execute each and every branch. In branch coverage, the test cases should be designed in such a way that it should be able to execute each and every branch given in a program code. Only then we can be sure with our testing strategy. Then we have condition coverage. What is there with the condition coverage? If there is, it is designed in such a way that in a conditional expression, both true and false values should be assumed for all the literals. Suppose we have this condition C1 and C2 or C3, then we should be designing the test case in all the way that both C1, C2 and C3 should be assuming all the positive as well as the negative values, and so that all the conditions can be checked. Then comes the path coverage. Path coverage, this is a testing strategy which requires designing test cases in such a way that all the linearly independent paths in a program are executed at once. Now, control flow graph describes the sequence in which the different execution instructions of a program gets executed. We will be looking at the example how to draw the control flow graph. Suppose we are given with this code: a is equal to 5, b is equal to a into 2 minus 1. So we know that if the flow of control will move from 1 to 2 instruction. So we'll be drawing this thing. There will be one node for each statement, 1 and 2. 2 is dependent on 1, so there will be graph from 1 to 2. Similarly, look at the next code. This is if a is greater than b. If a is this is first statement, then c is 3, else c is equal to 5, c is equal to c into c. So this is the first statement. If a is greater than b, so 2 is also dependent on this, 3 is also dependent on this. Finally, the value of c that is to be computed, that is dependent on both 2 and 3. So there will be edges from 2 as well as 3. This is how the control flow graph is drawn. Next we'll be looking at this code while a greater than b. This is first statement: b is equal to b minus 1, b is equal to b into a, c is equal to a plus b. So first statement, while a is greater than b, the controller flow will move to second statement, that means 2 is dependent on 1, then b is computed as b into a, so 3 is dependent on 2, there will be graph from 2 to 3. Then the statement closes over here. This is dependent on the first statement, so there will be back statement from 3 to 1. And finally, how c is computed: c is equal to a plus b, which is dependent on 1, so there will be edge from 1 to 2. This is how the control flow graph is drawn. Control flow graph is drawn in a now similarly you can do it also. This is one example. Suppose this is the code given to you where a function is there sorry, in which we are supposed to compute the GCD where the value of parameters passed are int x and int y, while x not equivalent to y. This is the first statement. Then we have if x is first statement is there, if x is greater than y, 2 is dependent on 1. Then we have x is equal to x minus y, else y is equal to y minus x. So 3 and 4 will be dependent on 2, 5. Then we have 5 statement, fifth, which again is dependent on third and fourth. Also this is a closing parameter for the statement started in 1, so there will be edge from 5 to 1. Finally this sixth statement, this will be dependent on 1 because there is closing brace in the last statement. Return next, this will be dependent on 1, so there will be edge from 1 to 6. This is how the if the set of paths is linearly independent of each other, then no path in the set can be obtained through any linear operations on any other paths in the set. So this is one of the method in which we can compute. There are certain matrices that is very important from examination point of view. This is normally asked in examination, that what is Macabe's cyclometric complexity matrix. This is normally asked. There are 3 ways to compute this thing. We can find out the how that is computed. This is first method is this is equal to E minus n plus 2, where n is the number of nodes in the control flow graph, E is the number of edges. From this you will be able to compute the number of linear independent paths or Macabe's cyclometric complexity. Second way is we can find the total number of non overlapping bounded areas and add 1 to it. You will be getting the Macabe's cyclometric complexity. Last method is it can be also computed by computing the number of decision and loop statements of a program. Now if n is the number of decision loop statement in the program, then Macabe's cyclometric complexity, this is equal to n plus 1. This is all with the for some of the basis of the white box testing. In the next we'll be taking up that how that is to be performed, and some additional testing strategies will be